Welcome to the Explainer. Today, we're jumping right into this fascinating intersection of gritty, heavy industrial logistics and absolutely cutting-edge mobile architecture. We're going to break down exactly how 905 Wood is operationalizing full-stack edge AI, specifically on the Pixel 10 Pro, to transform chaotic, real-world construction waste into a verified, highly lucrative digital asset. If you want to understand the architecture of the circular bioeconomy, well, this is an absolute masterclass. Our core rule for this system: chaos goes in and verified audit-proof purity comes out. Okay, let's dive into this. Here's our architectural blueprint for today. We'll start with the data anarchy problem, move into architecting the Sentient Bridge, look at the edge and AI and hardware stack, check out automated RFQ and logistics, break down the triage and compliance gates, and wrap up with the digital product passport.
Section 1. The Data Anarchy Problem.
So, the North American industrial core is facing some massive geopolitical and regulatory pressures right now. We're looking at a rapidly tightening landscape shaped by USMCA, trade wars, escalating tariffs, and, this is a big one, a fast-approaching 2029 Ontario landfill ban that will literally make dumping clean wood illegal. The old take-make-waste model, it's hitting a massive regulatory wall. Which brings us to a really compelling question. How does a consumer smartphone act as a shield against international trade wars and escalating tariffs? I know, it sounds almost absurd, right? Juxtaposing these massive macro supply chain crises with a micro on-device edge AI solution. But out on those muddy job sites, that is exactly what's happening. And this brilliantly illustrates the paradigm shift we're talking about. Look at the stark difference here. The old way of managing waste is pure analog vulnerability. You know the drill: handwritten, coffee-stained paper tickets, massive contamination risks, and total regulatory liability. But the 905 Wood way flips the script entirely. By introducing cryptographic lineage, so a highly secure, unbreakable digital trail, they create auditable digital records and verified purity. The wood isn't just trash anymore, it's a fully generated, trackable asset. And the financial engine driving this is incredibly powerful. Check out this chart showing exposure to the CIR-CIL levy, which is a regional waste tax. If a load is classified as mixed commercial waste, it gets hit with a punishing $60 per ton tax. Ouch. But if you can technologically verify that load as clean wood diversion, that levy drops to just $5 a ton. To put that into perspective, when you're running massive 144-yard walking floor trailers that hold over 18 tons, you are looking at over $1,000 in immediate arbitrage savings on a single truckload. It's essentially decoupled billing, where the customer sees those avoided levy savings instantly.
But those savings are really just the beginning. See this number? $262. That's the carbon dividend yield per ton. By guaranteeing the absolute purity of the feedstock, 905 Wood converts that scrap wood into pyrogenic biocarbon, which is essentially high-grade charcoal that permanently locks carbon away. They are effectively turning a disposal liability into a highly lucrative ESG asset that generates verified carbon removal certificates.
Moving right along, Section 2. Architecting the Sentient Bridge. So, how do they actually pull this off at an industrial scale? They call the solution the Sentient Bridge. Think of it as the technological workflow that bridges the gap between a chaotic, messy demolition site and the hyper-clean, heavily verified requirements of the bioeconomy. As we mentioned, the core narrative thesis guiding every single engineering decision here is this: chaotic waste goes in and verified, audit-proof purity comes out. Every single time. Let's look under the hood. Section 3. Edge AI and hardware stack. To make this system work, you need serious computing power exactly where the material is ingested. Try to contrast the gritty, massive 144-yard walking floor trailers with this pristine, ruggedized hardware stack out there in the elements. They are utilizing the Google Pixel 10 Pro, but entirely as an industrial computing core. It's powered by the Google Tensor G5 chip with a dedicated edge TPU, secured by the Titan M2 hardware root of trust, and running Android 16 with the Light RTA stack. It is, for all intents and purposes, a supercomputer operating right there in the mud. Now, what's really wild about this is the sheer scale of the models running locally. You have the 2.3 billion parameter Gemma 4 E2B model handling the initial multimodal intake. Then, the larger 4.5 billion E4B model steps in as a dual consensus guard to double-check any ambiguous materials. Plus, there's a massive 26 billion parameter mixture of experts model for regulatory cross-referencing.
Thanks to NPU acceleration and advanced processing tricks like speculative decoding and turbo-quant compression, all of this incredibly heavy AI inference happens entirely on the edge. Absolutely no internet connection required. And because we're out on the field, it has to be impossibly fast. The whole system operates on a strict 2-second rule. From the exact moment a photo or video is captured, the Gemma classification must render a provisional result in 2 seconds or less. And since this is designed for operators wearing heavy safety gloves on active, dangerous sites, the UI relies on an authoritative, high-contrast black, white, and safety orange design with clear, tactile feedback. It has to be totally frictionless and instantaneous.
Section 4. Automated RFQ and Logistics.
Interestingly, before a truck even arrives on site, this digital architecture is already hard at work. The process kicks off on a high-speed e-commerce backbone. The automated request for quote system instantly computes the estimated weight based on the bin volume. So it converts a massive bin size directly into a mass estimate, and then automatically surfaces that exact regional waste tax spread as the headline savings right there on the quote. Through a seamless web-to-voice handoff, the financial logic and carbon dividend estimates are completely secured before a single truck is ever dispatched.
Moving to Section 5, Triage and Compliance Gates.
Once the material actually arrives at the hub, we hit the most critical stage of the entire operation, sorting the safe from the hazardous. The absolute biggest danger here is something called the visual fallacy. This is the terrifying reality where chemically treated, heavy metal-laden wood, like weathered gray pine hiding highly toxic CCA treatments, looks absolutely identical to clean, virgin timber. Human eyes will literally fail here every single time. That is exactly why dual-model AI consensus is fundamentally required.
Let's see how this builds, because to combat that visual fallacy, the system relies on a very strict 4-step escalation ladder. Step 1 is the visual triage on the Pixel 10 Pro. Step 2 is semantic audio monitoring. Using Gemini Nano, the phone's NPU actively listens to the driver's audio notes. If a driver casually says fencing or railway ties, the AI instantly flags it, even if the wood looks perfectly clean. Step 3 escalates to an atomic-level scan using an XRF sensor, checking for heavy metals like arsenic or lead. And finally, Step 4 maps all this data against Ontario Regulation 347 using retrieval-augmented generation.
So the crucial takeaway here is that the precautionary principle rules supreme. The rule is reject unambiguity, always. If the on-device E2B model and the E4B model disagree, or if the confidence score falls into that tricky amber band of 70 to 85%, it automatically triggers a hard stop. It requires a human and an AI consensus miss to breach this system, which makes it incredibly secure.
Finally, Section 6, the Digital Product Passport. All of this rigorous intake and triage leads directly to the final, most valuable output. This is the exact moment where physical wood officially becomes a digital asset. Cloud AI, running on Gemini 4.5, powers what they call explainable compliance. It uses advanced database retrieval to cite the exact, specific Ontario Regulation 347 waste management codes used to accept or reject that specific load. Then, that Titan M2 secure element on the phone seals the chain of custody with a 2-second haptic lock stamping it with GPS location, a precise timestamp, the model version, and a kernel hash. The resulting Digital Product Passport PDF is PIPEDA compliant, legally defensible, and 100% court-ready.
By wrapping heavy logistics in its brilliant full-stack edge AI, 905 Wood hasn't just improved a process, they've fundamentally reclassified waste as a certified, duty-free asset. It's a total game-changer. But it leaves us with an incredible final thought to ponder. What other chaotic, analog industries are just out there right now, waiting for their own digital refinery to step in and find clarity in all that chaos?